This video talks about how to construct the C chart in Excel. So here I used the example as in table 8.5. So this is the count of nonconformities of the canons that are inspected. So the C chart is different from the P chart. C chart is to control the count of nonconformities. So for one nonconforming unit in the P chart, it can have multiple, can have many nonconformities. And the subgroup size actually is just 1 in the C chart. So we just inspect one unit in each of the subgroup, and then you count the number of nonconformities on this one unit. So here we have the C values, and then the C chart is based on the Poisson distribution. So first, we should have the C bar value, which is the sum of the CI, the sum of the nonconformities, divided by G, the total number of subgroups. So first, for the number of subgroups, we use a count function to count how many subgroups we have. So you use the equal sign and then count. So you can count either the subgroup, like the model series numbers, or you can count like this C column, the count of nonconformities column. And then it returns to 25. So we have a total of 25 subgroups. And then the sum of the C values. So then this is the sum of the nonconformities. So this is the total number of nonconformities on these 25 canons that we have inspected. And then the C bar value is the sum of the C divided by the total number of subgroups. So that gives you 5.64. And now we have to establish the trial central line and the trial control limits. So the trial central line is just the C bar value. So then you refer to this cell, the B33, and then you have to fix the address. And then you can copy this down for all the 25 subgroups. And then for the lower control limit and upper control limit, we use this formula because this is based on the Poisson distribution. Therefore, it is established as the C bar plus and minus 3 times the square root of C bar. So the square root of C bar acts as the sigma in the Poisson distribution. And therefore, you can use the C bar minus 3 times the square root of C bar. Okay. And in this case, it returns you a negative number. So remember what we did in the P chart is that we use a max function to take the max of this formula, the lower control limit formula, and 0. And therefore, it will push every negative lower control limit to 0. Okay, and therefore we have a 0 for the lower control limit, and you can copy this down. And then for the upper control limit, this is C bar plus 3 times the square root of C bar. Okay, and we can round this to the third decimal place. And now you can copy this upper control limit for all your subgroups. And now for the revised control limits, we have to first see whether we have assignable cause for all the subgroups. So we use an if sentence to see if we have any text in these comments. So if there is a comment, that means there is some assignable cause. Otherwise, there is no assignable cause associated with the subgroup. So now we use the if. And then for the logical test, we use another function, which is text. So we want to see if we have any text here, and then you choose the comments. If this logical test is true, if we have some text here, then we return 1. That means there is an assignable cause. Otherwise, we return 0, which means there is no assignable cause. So like for the first one, there's no comments, so no assignable cause. And then you copy this down. So as you can see, we have some 1 here associated with the comments. We have also a 1 here. And next, we need to test if the C value is out of control. So we have to check whether the C is between the lower control limit and upper control limit. So we still use the similar logic as we did in the P chart. So if the product of C minus the lower control limit and then times the C minus the upper control limit is greater than 0. If this is true, we return 1, otherwise we return 0. Okay, so this will tell you whether you have an out of control point or not. And then you copy this down. So now you can see we have 3 ones in this column H. We have 1 associated with the MY132. We have a 1 associated with MY172. And then a 1 with MY278. So now you have to decide whether you want to discard the out of control point. So this should be a combined criteria with the assignable cost and out of control limit. So you use this indicator times this indicator. If both of them are 1, then we will discard. Okay. So now you can see that we have 2 1s here for the discussion. For this out of control limit point, actually we do not discard because there is no assignable cost. So we just assume that this out of control is due to some natural variation of your process, and therefore we do not discard this subgroup. Okay, so we only discard 2 subgroups that are both out of control limit and due to assignable causes. So here are the 2 subgroups that we discard. And now you have to decide the sum of the discarded C's, which will be subtract from the numerator, and then you have to find the total number of discarded subgroups. So how many subgroups you have discarded, and then subtract this number in the denominator. Okay. So for the sum of discarded C's, we use sum product of the C value array, and then the second array is the discard indicators. Okay. And then for the number of discarded subgroups, it's actually easier than the p-chart. You do not have to use the sum product, but just the sum of the column for the discard decision. So just sum up like how many ones you have for the discard. Okay. And then for the central line, for the revised central line, that will be the sum of C minus the sum of discarded C's. So this will act as the numerator, the updated numerator. And then for the denominator, that should be the G, the number of subgroups, minus the number of subgroups that you discard. Okay, so that gives you 4.652. And then we want to round this value to the 3rd decimal place, and therefore it's 4.652. So now for the revised central line, you refer to this cell, right? And then you want to fix the address. So now we can copy this down. And then you can find the revised lower control limit and upper control limit, still using this formula, but plug in the C bar new here. Then for the upper control limit, so we put a round function out of this UCL formula, and then we want to round it to 3 digits after the decimal point. So now you copy this, and now you have got everything in the table, so you can draw the C chart with trial control limits and the C chart with revised control limits. So I'm not going to show that again. It's just like a repeated operation as we did in the P chart. So I will leave you with the exercise 20 as your homework. So you have to complete all the highlighted fields here. And then you also need to draw the C chart with the 12 control limits. Okay, so that's all for today's lab. Good luck with the homework.